Hi, we're going to look at another first derivative test example. So we have ourselves a function, a nice normal looking function, x cubed minus 6x squared plus 15. So kind of thinking about this function, nothing really weird. We don't see any discontinuities, no vertical asymptotes going to pop up, no corners, nothing crazy. So it's a nice continuous differentiable function. You should hopefully at this point start looking at the function and realizing that they look very normal. And so what we're going to do is we're going to do that first derivative test. So the first thing we do is we find the critical value. So we're going to take the derivative. And so there's my first derivative. We're going to kind of keep him in mind. We're going to use him a couple times here. And then I'm going to take that derivative and set it equal to 0. Okay? Now the reason I'm doing that once again is that minimums and maximums and other possible inflection points, you'll learn about those in later videos, occur when the derivative equals 0. Okay? That's basically the horizontal tangent line. Things are bottoming out or maxing out. So you got to be able to solve this, so hopefully you can factor a little bit with me here. So this is 3x times the quantity x minus 4. And so you get x equals 0 and x equals positive 4. Now, what these are, once again, these are critical values. Critical values occur where there's discontinuities. Got to pay attention to those. Where the function is not differentiable, got to pay attention to those. And right here at the critical value, or when the derivative equals 0, which is normally what we're looking at. Okay. So, what's that mean? Is x equals 0 a maximum value? Is it a minimum value? Is it nothing? What's happening? And so we need to do the first derivative test. So we need intervals. And so our interval is going to be from negative infinity to 0, from 0 to 4, and then from 4 to infinity. So those are our intervals we're concerned with. Kind of see how it broke up into 3 pieces. And so then we need a test value. So in here I'm going to use -1, and here I'll use +1, and here I'll use 5. Don't pick things crazy. I'll have kids pick like 100. Don't do that to yourself. Because what's going to happen is everywhere in this interval, everything is going to behave the same. So we're going to find the sign of f prime. So we're going to put -1 into my first derivative, and we're going to see if it's positive or negative. So if I put -1 in here, I think I got space to do f prime and -1, I get 3 times -1 squared minus 12 times -1. Well, that gets me a positive 3 plus a 12, so that's positive 3 plus 12 is 15. The big thing is a is positive. Hopefully you can recognize that. F of prime of 1, we're going to put in 1 now, and to be honest, I'm expecting a negative value at this point. If I don't, I'm going to double check my work, because it is possible to get a positive and then a positive, but that's not as likely. So I'm going to put 1 in, and so when I put 1 in here, I'm going to get 3 times 1 squared. That's going to be 3 minus 12 times 1. That's a -12. So 3 minus 12 is -9. So that's a negative value like we expect. And then here, I'm expecting to go from a negative to a positive. These normally switch. It's not always, though. So we're going to pay attention to f prime of 5, and if I put that in, I get 3 times 5 squared. That's 75. 75 minus 12 times 5, that's 60, so I get 15. And so I'm back to positive. And so what I can conclude is that the function's increasing from negative infinity up till it hits 0, and then it starts decreasing after 0, and then it starts increasing again. So what's that mean? That means I have x equals 0. I'm going from an increasing to a decreasing. That is a maximum. And then x equals 4, from decreasing to increasing, is a minimum. I'm going to graph it just to show you. Okay? So let's take a look at the original function. So I'm not going to put in the derivative. I'm putting in the original function. Well, come on. Okay, and just looking at the graph here. Okay, big wide graph. Let's kind of change our y value so you can see a little clearer. So you can see the function's increasing up until x equals 0. That's a max. Decreasing from 0 to 4. Then it bottoms out. We have a minimum. And then it starts, well, it helps if I show you the picture. So there we go. So you can see it's increasing up until x equals 0, decreasing from 0 to 4, increasing from 4 up to infinity. And so you can see my intervals right there, and you can see that I concluded that already, which makes 0 a local or a relative maximum and 4 a local or relative minimum. Okay? Hopefully this helps you out. Okay? But once again, you're not going to get to use a calculator on these type of questions. That's why we're going through this work. Okay?